Welcome back, everyone, to the Xamarin Show. I'm your host, James Montemagno. Today, I have my best friend in the entire world, all the way from Bangalore, India, Nish Anil. Nish, how's it going?
Very well. Thank you so much for having me on the show. It's been a really long time. We have been waiting to do this.
It has been a while, although, we do have a one-on-one and we talk every single week. And I was like, you're always talking about microservices. We should have you talk about microservices on the show. And Nish and I, we've worked together for what, like 9.5 years now, I think?
Yeah, probably close to 10. We should celebrate.
I know. It's kind of crazy. We're all getting like our 5-year, plaques from Microsoft and things like that. But Nish and I worked together back at Xamarin in our advocacy org there, where we talked all about mobile applications. And Nish still doing mobile applications now, really focusing on microservices. And Nish, I never know what microservices are ever. So can you help me explain to what's going on with microservices?
Yeah, I imagine this to be a regular conversation that James and I usually have on this. James is always like, I don't understand microservices, and we get to this conversation like, okay, this is what microservices is, and we go on and on. So we thought we'll just do the show, right? I mean, it's going to be helpful for all the Xamarin developers over there to understand what really happens in the behind the scenes on the backend side. So I've been working with Xamarin I worked with Xamarin for a very long time. I was an APAC evangelist, did a lot of Xamarin, but then 2-3 years ago, I moved to the backend side of things, and I've been focusing on something called as architecturals, .net/architecture. That's the page that you need to go and visit. If you haven't seen it, you should give it a try. It has amazing set of resources. And the way I look at my job now is I try and help developers build production-ready apps with .NET, and that includes the latest and greatest like cloud natives and microservices and so many things like that.
Yeah, it makes sense. And I think that, creating a powerful backend for our mobile front ends is super important. And I just had Brady on recently talking about Web API and some new things in ASP.NET Core. And, microservices are sort of natural extension, but there's a lot in there. So I figured maybe you could just walk through what the heck, container, pods, clusters, all these words that are so important in the world of microservices.
You already put in a lot of jargons there.
That's what I do.
So we'll get started with, my screen. We have what are microservices. I want to get started with something very, very basic, and we'll go from there, explaining all those jargons that are actually involved in making microservices development easier, right? Mm-hmm. Talking about microservices, basically, microservices are the microservice architecture. It's nothing but a design pattern which basically says your application has to be structured as collection of smaller services. And each service focusing on a single business functionality. And that is the key part. A lot of people think breaking down services into multiple web API projects, that's not a microservice technically. I mean, that's a service for sure, but that doesn't add up to the microservices architectural design pattern that it states, right? The key point is the services focuses on its own business functionality. To explain this better, if you look at the monolithic side of things, the way we used to do before, I wouldn't say before, I mean, it's something like, monolithic and microservices are two different style of architecture. It may be right and wrong depending on the kind of application that you're trying to build right now. So in monolithic, previously for forever, we used to always, split the applications, right? By modules, or in terms of, for example, like you have a layers, like you have a database layer, data access layer, this services layer, this web layer, and but then when this has to be deployed, they are all actually composed into a single deployable unit, and finally scaled into multiple VMs and whatever the infrastructure is, right? I mean, this works great, and it has been working great for a long time. But today's applications requires faster development, right? You deliver things faster. We are talking about shipping things to productions 100 times a day. There is a bug in the production. You find it in the afternoon. You want to fix it by noon. By evening, and so on, right? Similarly, when it comes to that's what you will be able to achieve if you start thinking in terms of how do you design applications in a microservices architecture style, where once you have defined the business functionality and they become loosely coupled, they're also independently deployable. So that means these layers can be actually technically they are services now, and they can be deployed into multiple VMs, and they can have multiple scale sets, or it can be in single VM, or it can be in a number of VMs as well. And the thing that actually binds these things together, a system that can actually try and understand how to do these things, is one of the jargons we spoke about earlier, is the Kubernetes world of things, where with Kubernetes, and I think it's possible to do that. And Docker comes into picture, where where you want to package this application into smaller deployable unit. That's where the Docker comes into picture. And so just to let you know that, you don't need Dockers and Kubernetes for microservices development, but having this kind of tooling kind of helps do things faster and kind of like stick to those architectural styles very easily, right? So let's talk about containers. What are containers? I mean, previously, if you look at the VMs, like how things work in VMs is like, you have an infrastructure, you have the host operating system, then there's a hypervisor, and then your deployable units are part of the VMs. And the thing with VMs is it has a guest OS as well, right, along with your app and binaries. But when it comes to
Windows or Linux or whatever, right? Kind of that's what you're talking about there.
That's correct. And when it comes to containers, if you look at, they are also isolated, but they have to be looked at more like a single process, right?
Okay.
Those processes. And there is no guest operating system here. And that's why you can think of it like a very small deployable unit, which also means, like, I mean, when it comes to VMs, if it has to be run, from scratch, it takes about minutes, like, a couple of minutes to just get started, because the host has to pull in the guest OS, it has to start up, it has to set your drivers right, and then your application, right? But these are like just like another process. So it's like milliseconds your application can come up when they are packaged into containers, right?
So this is really cool. And you just said a lot of words. You're talking about Docker and files and this sort of decoupling in a way. And this is really nice, because I really like that sort of architecture pattern that you were talking about is, hey, I have this little sign of service that's my login service or my coupon service or whatever. I'm thinking of like Amazon.com, or when I log into YouTube, right? There's so many different services, and they can all work independently, which I think is really, really cool about that, and they're deployed separately, so they're not reliant on each other in a way.
Yeah, that's correct. As I mentioned, the most important point is to split by business functionalities. So, and one thing I forgot to mention earlier was, even the independent services are actually controlled by smaller teams. So every single team, they look at this particular service as an application itself. So they have their own CI/CD pipelines and things, and that's why they're able to ship features or roll out features and update bugs very sooner without breaking the entire application, because they're independent.
Yeah, so they can work faster together as multiple teams instead of one monolithic team trying to all be dependent on each other.
That is correct.
Yeah, very cool.
Right. So talking more about containers, I mean, as I mentioned earlier, there's a hardware, there's a host operating system, there's a hypervisor, and your VMs are actually isolated, and the apps are actually sitting inside it, right? The problem with this VM approach is it's expensive because, when you're scaling up app, you're scaling up multiple times, but there is a lot of resources that could have been utilized in a single VM itself, which is not possible. And that's why when you use something like a container, you have this Docker daemon that is able to manage these, run these containers. So chances are you can actually, see the resources which are not utilized, move the containers there, and then kill the VM that you don't need. And you can also save a lot of cost doing so, right? So I say Docker engine here, but then in production, you probably may be using something like a Kubernetes orchestrator, which would do these things automatically for you. So giving, you have questions, James?
Yeah, I mean, I like this idea that it not only is saving us money, but it sort of is optimizing our different resources, right? Because here you're sort of shifting, your different containers from VM to VM. But I imagine the opposite is true too, which is if you have big spikes, let's say at a holiday sale, you can easily scale up specific services. If for example, I'm thinking of when I buy things on BestBuy.com or something like that. Not a sponsor of the show, but when I say I'm buying something on BestBuy.com and they're having a holiday sale, they might actually have like their coupon service or like their specific sale, like point of sale, like checkout service completely separate. And that can scale up completely, where maybe the engine that is, creating new accounts or doing something else can be scaled down. Is that correct?
That is absolutely right. And that kind of, availability and scalability is given to you by the cloud native technologies like Docker and Kubernetes. So it makes it easier for us to kind of like have a system which exactly you said, rightly said, the business requirements, the way it comes up, it can be managed with these kind of systems in place.
That makes sense a lot. I think that's something really cool because I'm always sort of taking my entire app, my entire package, and just right-click publishing, and then everything's up there, right? And then if I need to make one little tiny change, I have to redeploy the entire thing again, and that is probably not the greatest.
Yeah, so good that you brought up some of the e-commerce clients that you spoke about, and we have something called as eShop on Containers, which is a reference application, and it is one of our popular samples out there, and it kind of like gives you those insights into how an e-commerce application could have been built. And the reason why we picked up e-commerce and microservices does not have any kind of like it's for certain businesses or something like that. It could be any businesses out there. But then e-commerce is easier to understand because we all use it every day. So that's the reason why I built up the sample, which is more like a real world stuff. So if you look at this architecture, there's in reality, the production-based applications are much more complex than this. But then this is a reference sample, so you can just get started with these. So if you look at on the right side, there are multiple services, as you rightly said. If there is a need for catalogs, for example, to go up during a particular sale, we can actually independently scale the catalog. And similarly, if ordering has to go up during the holiday seasons and other things, like, we can scale up independently. And what brings these services independence is not only the way it is built using Docker and other things like that, but it's also the important thing is the databases, if you look at here, they are completely different. So in microservices world, there is no single central database. So which means every single microservice owns its own data. They have the data with it. So that means now I can think of even deploying it 100 times a day because I'm in full control of this application. And the way these services will work with each other is through the endpoints. They never query the databases of each other directly, not like the relational world where you have the relational tables and things like that, but it is directly through the endpoints. And that is something like if, for example, when order has to be placed, you want to check if there is, if this item is in stock, you query the catalog and say, check the item is stock, and then you make the order, right? Similarly, when the order is placed, you want to let the payment service to come in and complete the payment. You don't directly call the payment. Instead, you can use something like an asynchronous messaging, which is event-driven programming, where you can actually notify using an event bus like RabbitMQ or Azure Service Bus, saying the order is placed for this item, so the payment can actually subscribe to that and pick and then process it further. So you can see how these things are totally decoupled in the world. That way, independent services can be scaled, or you can actually even test out few features for your customers, right? You can have a couple of more features rolled out into that particular cluster, and you can load balancers can kind of decide on what traffic to be taken to and other things like that, right?
That makes sense. So you can do some A/B testing, you can add some features, remove some features, you can do a bunch of stuff. Now, we really wanted to use this video as like a 101 kind of overview. So before we do this, and we have another video like right after this, so you can see we're actually going to implement some of this stuff. So what I want to talk about really quick is define for me a container.
Yep. So container is basically an instance, a running instance of an image. So that goes back to understanding what is an image, right? So image is, think of image like a packaging unit, like, all your application and its dependencies are actually packaged into a single image, and they're immutable in nature. So once the image is created, they cannot be changed. You can only create new image out of it, right?
Okay.
So that's how. And Docker is the tooling, most famous tooling that is used for building the images today. Right? Container as a concept has been existing in Linux for a very long time, but then Docker popularized it, I would say. And Docker, it's a company. It's also the tooling that enables this image creations and kind of like run these containers in wherever the Docker daemon runs.
Okay, cool. So you have a container, you have an image, you have to put it somewhere. I'm understanding that there's something also that is from Docker, but also in Azure that are called hubs or registries. Is that correct?
All right. So talking about container registry, I think it's a very good and important point. So I look at container registry as more like a GitHub for your images, right? So somewhere where you want to store all your images, where when it comes to the infrastructure, you want to go and deploy it, you want to pull the images. So that's like the hub, the Docker hub that you're talking about, is one of the popular container registries, which is also public in nature. So you can actually give a URL and you can pull the image. But there are also private container registries like ACR, which is the Azure Container Registry. So if you are working in enterprises, you want to secure your images because these are not something which for the world to consume, it's for your businesses to consume. So you want to secure it. So you will work with an ACR. And for example, if you're going with Kubernetes, you may have it in the same group. So it can be pulled in easily and securely between the Kubernetes and the container registry, things like that.
Okay, perfect. Last question before we wrap up. Keep saying Kubernetes and orchestration. What does that mean? Because now we have containers and images and hubs and registries. Final piece, hit me.
Yeah, Kubernetes is like a system that knows how to run the containers, right? So it's simple as that, right? So for example, like as I mentioned, like, initially when I talked about VMs being like when there is resource utilization to be done, the VM can be shut down and the containers can be moved into another VMs. All these things, you can't manually do it. So you need a system to do that. And that is what Kubernetes is all about. They call it orchestrator. It is the most popular architecture. So now it's become the de facto standard. There are other orchestrators like Docker Swarm, I think Mesos and other things, but Kubernetes has become the de facto standard, right? So people talk about Kubernetes like as once you created the images, you want to run it somewhere, Kubernetes will enable that. And the thing with Kubernetes is basically it's a contract-based things. Like, you define to Kubernetes what you want. So you can tell what CPU you want, what resources you want, how many replicas you want, like what's your scale? Like you want do you want 2 containers running, 3 containers running? You tell Kubernetes, and that's a contract that you sign, which is called the YAML file. Which is a little tedious to write, but that is what Kubernetes defines, right? So Kubernetes will try to make sure the state is true to what the contract is signed. So that is what Kubernetes does for you.
Perfect. Awesome. Well, now we have our baseline of getting started with microservices and what they are. And now in the next video, Nish is actually going to walk through all of those buzzwords that he talks about. We're going to take some APIs, containerize them, put them in hubs and orchestrate them and do all the things. So tune in for that. Nish, thank you for giving us this 101 overview of microservices. And I can basically just watch this over and over again.
Thank you so much. Yeah, we'll do better in the next one with the demos and things like that.
Perfect. We'll tune into that one. It's going to be right on the next playlist. But of course, make sure that wherever you're at right now, leave us some comments. Put some comments on there. Initial will be tuning in and answering questions in there. And of course, if you like this video, give it a thumbs up. That goes in the Google algorithm of goodness on YouTube and recommends this video to other people. I'm pretty sure. Who knows? Also, subscribe and hit that notification bell so you become part of the notification squad right here on YouTube. So until next time, I'm James Montemagno. This is The Xamarin Show. Thanks for watching.